So let's do that last part of the example problem on page 407. It says, to make magnesium hydroxide a major component in some stomach acids, hot water vapor is passed over solid magnesium. And then they give you the chemical equation for that. And they say, if 4.5 liters of water vapor at 200 degrees Celsius and 4.94 atmospheres are passed over excess magnesium, how many grams of magnesium hydroxide will be produced? Okay, so real quick, let's put our equation up there. MgOH2, H2O. Okay? So we always start with what do we know, what do we need to find out? So they asked us how many grams of magnesium hydroxide will be produced. That's this guy. Put grams question mark. That's our end goal. We need to figure that out. And then they gave us a bunch of information about the water vapor. So looking at this, we should be able to see this is the water, underline it. This is the information we know we need to get over here. We're going to use our moles to find out our stoichiometry, okay? So let's go ahead and, so you can see right now, they gave us a bunch of information about pressure, temperature, all that stuff of this. And we need to get grams here. So you should be thinking, I need to get to moles, that's my first goal, moles here to get to moles here. So it looks like we're going to be doing it opposite from last time. So let's put perv nerd up, PV and RT. Let's list what we know. Pressure, they said, was 4.94 atmospheres. Fine, hold on, I'm listing all these things really quick. Okay, volume was 4.50 liters. 4.50 liters. R, go ahead and put it 0.0821. You're learning it. Look at you, smarty pants. Moles, Kelvin. Temperature was 200 degrees Celsius. So now we have to take that 200 off to the side and add it to 274. Okay, just do it right here. 200 and 273. Okay. And it was 200.0. So now we can grab this guy, so we can go out to here. So it looks like it's going to be 473.2. Okay, so put that in for a temp, 473.2 Kelvin. Now, this is the only thing we don't have, which is good. We're looking for the number of moles so that we can go from moles to moles, okay? That's our end goal. So we're just going to go ahead and rearrange our equation perv nerd to solve for n. So I'm going to divide, and we'll find n. So go ahead and plug everything in. Looks like I got pressure, 4.94 atmospheres, times volume, 4.50 liters, over R, 0.0821, you're learning it, ta-da, over moles, Kelvin, times that temperature, which is 473.2 Kelvin. Now, fun part, cancel all of your units that you can, atmospheres, liters, kelvins, you're left with moles, that's good, that's what I'm looking for. So if I crunch that, I'm ending up with 0.572 moles. Okay, now, should become apparent, now we got moles here, we just need to go to moles here and to grams. So I've just got some stoichiometry going. So I'm going to erase this. It served its purpose, and we'll leave that up. So I have 0.572 moles. Now keep in mind that was moles of this, H2O. And we need to get to moles of this. So mole H2O, moles MgOH2. So use your coefficients. I've got 2 here, 1 here. I can erase this now. So if I crunch that out, I get 0.286. 0.286 moles of this guy. The last thing I need to do is go from moles of it to grams. So 0.286 moles of MgOH2. And we need to figure out what the grams are. So grams, MgOH2. So I just use my periodic table, find what it is. I'm just going to cheat and use the stuff in the book, 58.3. So if I crunch that out, remember these are canceling, I'm going to end up with an answer in grams, 16.7 grams of this guy, magnesium hydroxide. Okay, that's what we were looking for, grams of that. So what we really did is we're combining our ideal gas law, perf nert, and we're using stoichiometry with moles to move from one gas to another. So we did perf nert over here with all this information, found moles, moles to moles, moles to grams. Okay. I think that's all you need to know. So let me know if you have any questions. Otherwise, next week we are going to go through the review problems and the practice problems.